Hello. Today we're going to be finding area in the coordinate plane, sort of like we've found perimeter in the coordinate plane. You'll need to know your area formulas for squares, rectangles, and triangles for these, and I will talk about those as we run into them. So, very similar to how we started off with our perimeter problems, we are going to put those coordinates into Desmos just so we can see what our picture looks like. So type in the ordered pairs exactly the way you see them. If you'd like to label them, I like to do so. You don't have to. You can do that. Oops, I did that in the wrong spot. Okay, make sure when you want to label it, you actually click that label line. And then last but not least, our last point, -2, -1, which if we want to label that is J. Okay, so we have a triangle here. So, good news is that we are not actually going to have to use distance formula. I'll explain that more in a second. The area of a triangle formula, I'm going to write that out so we see it. Area of a triangle is 1/2 times your base times your height. So in picture form, your base and your height need to be perpendicular to each other. Your height is not always a side of the triangle, and that's what's going on here. So we need to know B, we need to know H. If you have a vertical or horizontal, that's a good side to use for your B or your base. And so JH is going to be the one we are going to use for our base. Actually, let me undo that and write B in front. So B is going to be JH's side length. Since JH is not diagonal, it's a horizontal, we can just subtract the two coordinates that are different. And so that would be our x coordinates in this case. X coordinate of J is -2. The x coordinate of H is 3. When I do the absolute value of that, absolute value of -2 minus 3 equals 5. So my base is going to be 5. You could have also looked carefully at your graph and counted the units between J and H. It would be 5 units that way too. Now perpendicular to that is going to be the distance from H up to G, okay, vertically. So let's just count the units there. And so to go from H to G, I'm going up 1, 2, 3. So my H is going to be 3. So then now I just plug these things into the area formula. Area is 1/2 times my base, which is 5, times my height, which is 3. As per usual, we can have Desmos do that. Remember to type in 1/2 is going to be 1 divided by 2. Arrow over times 5 times 3. And we get 7.5. We are nearly done. One more key detail here is with area. We need to talk about not just units, but square units. So square feet, square inches, etc. They didn't tell us a unit at all, so we'll just say square. I'm going to abbreviate the SQ units. So the area of that triangle is 7.5 square units. The next problem we're going to look at is going to be a different type of polygon. So I'm going to clear out my Desmos, and let's get these coordinates typed in. So this time we have 4 points. We're dealing with some sort of quadrilateral. -2, 3, which if we would like to label that, I'm going to, is F. Next point, 1, 3, which is G. And then we have H, which is, oops, I did not mean to do that just yet. We have 1, -1, which if we're labeling that is H. And then last but not least, we have J, which the coordinates of J are -2, -1. Okay, let's look at our picture before we do anything else. That looks like we have some sort of square or rectangle. And so first of all, notice that all the sides are either horizontal or vertical. We can use that ruler postulate or just simply count units to find all of our side lengths here. We will not need to use distance formula at all, which is a lot easier to deal with. So let's go with our, let's just go in order. Let's do FG first. So FG, that's where we do the absolute value thing. Subtract the coordinates that are different from each other, which is going to be our x coordinates. Gx coordinate is 1, Fx coordinate is -2. If you'd like to do just most, you can. Absolute value of 1 minus -2 is 3. Now let's do G to H. G to H is a horizontal, or sorry, a vertical line. So the coordinates are going to be different are the y coordinates. We're going to subtract the y coordinates. So HY coordinate is -1, GY coordinate is 3. If I do absolute value of -1 minus 3, I get 4. Okay, and then let's continue on. I'm going to go H to J next. Again, it is a horizontal line, so we are going to subtract the things that are different, which is going to be the x coordinates. X coordinate of J is negative. I meant to do that in blue. X coordinate of J is -2, and the x coordinate of H is 1. When I do that, if you'd like to use Desmos, go for it. -2 minus 1 absolute value is going to be 3. And then last but not least, we have J to F. J to F is a vertical line, so the coordinates that are going to be different from each other are the y coordinates. Y coordinate of F is 3. Y coordinate of J is -1. If I do absolute value of 3 minus -1, I get 4. So the things we would be dealing with here are squares, rectangles, or triangles. We already did triangle. A square has all of the side lengths the same. Are all of these the same? No, they are not, but we have two sets of 2 that are the same. That means that we have 2 lengths that are the same and 2 widths that are the same. This means that this is a rectangle. The area of a rectangle formula is length times width. It doesn't really matter which one you pick to be the length or which one to be the width. I'm going to say that our length is 4, just for funsies, and our width is 3. I'm not going to use Desmos to multiply this. 4 times 3 is 12. So the area of my rectangle is 12 square units. For neither of these problems today, we had to use the distance formula, but if you had something that, for instance, was a rectangle that looked like this, where all of your sides were on diagonals instead of being horizontal and vertical lines, you would have to use distance formula for that. Just a heads up. That is it for today. Have a lovely